Hello, people. So, this morning, turns out for $49.95, you could buy 1 square foot of land in Scotland. Being a landowner in Scotland allows you to become a lord. So, from now on, you should refer to me as Lord Keelty. Doing physics. Okay, so we got this point charge system. Express the force exerted on the two. Remember, these are very specific. On the two by the -2. Okay, so these guys are opposite. That's going to want to pull this up in the air. Opposite charges attract. And let's start plugging in. They want force, right? Yep, force. That would be K. And we're going to leave out the positives or the negatives because it's just going to mess us up. We're going to take care of direction by our picture. That would be 2Q times 2Q all over R. Looks like this one's easy enough. That would be 4KQ squared, squared, over R squared. Easy enough. All right, it's going to be the force on by the -Q charge on that. Once again, negative, positive. These guys are opposite. That's a force of attraction. That's going to pull it this way. You know what? I should do that in blue. You know? So now we're going to do the same thing. Fe of the blue guy, we'll call this guy the blue guy, equals K Q times 2Q. Ooh, that should have been a squared. Right? Q times Q is squared. All over 2R. So that's going to be, pull that out, you'll get 2K Q squared over 2, would be, so why do I keep leaving this out? Squared. That would be 4R squared. That's a 4. Awful looking 4. Last part is do the sum of the forces. So these are vectors. The way you add vectors is you put the tip of one on the tail of the other. Boom. Draw a vector from the beginning of the first up to the end of the last. This is our resultant vector. That's what we're looking for. So, little Pythagorean theorem. So, C is going to be equal to the square root of the red guy. I'll do the blue guy first. 2KQ squared over 4R squared plus 4KQ squared over R squared. So once we square everything up, we'll have to find some common denominator to do the math on this one. So let's see. This is going to, I got space for this. Square root. I mean, everything I do is going to be under the root, if it looks like it or not. Square everything up. We got 4K squared Q to the 4th divided by 16 R to the 4th plus 16K squared Q to the 4th divided by R to the 4th. So let's see, this one will tidy up into 1 over 4, right? So if that's 1 over 4, this would be 1632/64 over 4. All right. Equals, just to show you that step I was doing verbally, This reduces to k squared q to the fourth over 4r to the fourth. And then to get a common denominator so we can add these two together, I got to multiply top and bottom by 4. So 16, 32, 64, that's 64 k squared q to the fourth divided by, oh, I left something out. Did I? Nope, I don't think so. Divided by 4 r to the fourth. Add them all together. We get square root of, if there's one of these plus 64 of these, you get 65 of them. 65 k squared q to the fourths divided by 4 r to the fourth. And that then, yep, reduces to that. Okay, last one. Yeah, just making sure that's the last one. There's that 4-point chart system. The above squares sides. Oh, each side is r. First thing I'm going to do, if the side of these things is r, right? And I've got to figure out the distance to the middle. Well, it's a box. So if that side's r, that means this side is r. And let me flip this onto another piece of paper. You've got a side r, another side r. You want that side, you're going to have to do the Pythagorean theorem. However, this side is the distance across the box, the square. You need a distance to the middle, so I'm going to have to half that when I'm done. That's how you figure out the distance to the middle. So it's going to be, right, c would be there. C is going to be equal to the square root of r squared plus r squared. So c equals square root of 2 r. Now, remember, that's the distance across the whole thing. We want half that, so it's square root of 2 over 2 r. So that's going to be our distance to the center. Be a square root of 2 over 2 r. Let me get everything right here. Each small square represents a charge q, so this is q, q, q. The large one is negative 4q. Negative 4q. Point O lies in the center of the square. Find the magnitude and direction of the electric field. Okay, so let's do our directions first. If you put a little positive test charge in there, that tells you direction of the field. So positive, positive, positive. That means this one is going to push it away that way. This is actually a pretty easy problem because 1, 2, and 3 are all identical charges, all at the same exact distance from that point. Means I've just got to do the math for those 3 once because you're going to have the same answer each of the 3 times. This one here is going to pull it that way. So if this guy pushes it that way and this guy pushes it that way, why bother doing the math if we know they're going to push with equal forces? These guys are going to negate each other, so we don't even have to do the math on them, right? This one pushes it that way with kq over r squared. This one pushes it that way with kq over r squared. I'm not going to do the math. Other guys, a different story. This little one down here, he's pushing that way. With, and according to the formula, E field strength is the force felt per charge. Put in the electrostatic force formula, and one of the q's cancel out, so it's going to be kq over r squared. We just got to be careful as to what our r is here. It's not just r, it's square root of 2 over 2r. So, first one I'm going to do is for this little q. You end up with electric field of the little q is going to be equal. Nah, I shouldn't put that there. It looks like we're multiplying by it. I wanted to make it a subscript. Would be kq over square root of 2 over 2r all squared. So let's tidy that up. You square all that, you're getting kq over 2 over 4r squared. Right? So that would be the same as kq over r squared over 2. And we just take the reciprocal and multiply, and you end up with 2kq over r squared. Something looks off to me. No, I think that's good. I'll do the other one in red. So, this one, I should have done this in red because it's pink, but I got it backwards. That's going to be, I'm leaving the negative sign out because these actually, if that's negative, this is going to pull it towards it. They actually work together and add up. So that would be 4kq over square root of 2 over 2r squared. Going to go through all this math, and you'll end up with 8kq over r squared. You can fill in the blanks. It's pretty much the same thing as you did up here. Since they are both on the same plane, no Pythagorean theorem needed. They both are in the same direction. They just add up. So 2kq's over r squared plus 8kq's over r squared gives you 10kq's over r squared. Electrical potential. If you look on your reference sheet, and I hope you have by now, this is one of the easier ones to do, because that electrical potential is just going to be k times a sum of all of the charges divided by not r squared, just r. So we're just going to do k, 1, 2, 3. That would be 3. I'm just going to do them all together because they're going to add up anyway. That would be 3q over square root of 2 over 2r. Definitely got my colors backwards. And then the v for the 4. And you got to use your sign when you're doing potential. It's going to end up being negative 4kq over square root of 2 over 2r. This, no matter how you look at it, is a common denominator. When you add these two together, you're going to get an answer of negative 1kq over square root of 2 over 2r. Play around with this. Negative 2kq over square root of 2r. I don't know. You could leave it like that. Math teacher might freak out and say you got to get the radical out of the denominator, but I don't think they do that anymore. So whether you do or not, I'd be happy with that as your answer.